So today we're going to do target 14 notes with unit 3, and this is the last target, this is the last lesson of this unit. So we're continuing with linear programming today. We touched on it a little bit last class with targets 12 and 13. Pretty basic stuff we did last class. The only thing we're adding today is a little bit of word problems. So don't let that freak you out. They're really not too bad. Basically, what we ended with last class with targets 12 and 13 was them giving us some equations of lines. We had to graph those. Then we shaded and found out where all 4 or possibly all 3 of those lines or of those shaded areas overlapped. And we tested the corner points to see which would give us a max or a min. So the only thing we're adding today is we're coming up with our own equations of lines based off of this word problem that we have here. So let's look at number 1. Dr. Lee's dentist practice is open for 7 hours each day. His receptionist schedules appointments, allowing half an hour for a cleaning and 1 hour to fill a cavity. He charges $40 for a cleaning and $95 for a cavity. Dr. Lee cannot do more than 4 fillings per day, and he cannot do more than 10 cleanings per day. Find the number of each type of appointment that maximizes Dr. Lee's income for the day. Okay, so with word problems, what we always do first is just kind of declare our variables. What do we want to say that x is? What do we want to say that y is? Well, we're only working with 2 things here in the word problem. If you can see, we're either working with teeth cleanings or filling cavities. So I'm going to say that x is just the number of cleanings. And then y is the number of fillings that he fills. So he's doing 2 different things. Cleaning teeth and then filling cavities. Okay, objective function, in parentheses, cost. How much money can Dr. Lee make? That's going to be based off of how much a teeth cleaning is and how much filling a cavity is. So we have to go back to our word problem and kind of look at that. So it says that if you read on the second or third, no, it says it's the third sentence, he charges $40 for a cleaning and $95 to fill a cavity. Alright, so that tells us how much each cleaning is and how much each filling of a cavity is. That's what my objective function is going to be. Basically, how much can he make total? Well, he can make $40 per cleaning plus $95 per filling. That's going to be our objective function. Now, in targets 12 and 13, we were given that function. We just had to come up with it on our own this time. So $40 per cleaning, I'm multiplying that by x, and I'm adding that to $95 per filling, so I'm multiplying that number by y. Alright, now my constraints. These are going to come from my word problems too. Alright, so here I have 5 constraints, 5 of them. Alright, so it says, let's see, Dr. Lee's dentist practice is open for 7 hours each day. Alright, so I know one of my constraints is going to be about time. They talk about time a little more in here. It says that his receptionist schedules appointments, allowing half an hour for a cleaning and 1 hour to fill a cavity. Alright, so what I'm going to do here for my first constraint, I know that it has to do with that sentence right there. Half an hour for a cleaning and 1 hour to fill a cavity, and he's only open for 7 hours. So he can only do so many things. Well, if I say that 1 hour is just 1, filling a cavity, I have y. So if I say that 1y would be 1 hour per filling of a cavity, I would have to say that a half an hour is 0.5, and it takes 0.5 hours for a cleaning, or 30 minutes. So I'm going to say 0.5x plus 1y has to be less than or equal to 7. Now that was already filled in for me, less than or equal to 7, because I cannot work more than 7 hours each day, or Dr. Lee can. Dr. Lee cannot work more than 7 hours each day. He's only open for 7 hours. So all of the cleanings and all of the fillings, all the time that takes, has to be either right under 7 hours or right at 7 hours. He can't go over. And then I have a little arrow right there. Now that arrow just means that I need to actually solve for y here, because what I'm going to essentially be doing is graphing all 5 of these constraints. I'm graphing all of these lines. So 0.5x plus 1y is less than or equal to 7. All I have to do here is subtract over 0.5x to get that y equals something. So when I subtract over 0.5x, I get y is less than or equal to negative 0.5x plus 7. All right, so there's one of my equations that I can graph now. Number 2, I have another constraint, less than or equal to 10. All right, so something has to be less than or equal to 10. So if I look down, I can find the number 10. It's right here. It says that he cannot do more than 10 cleanings per day. So either he can do 8 cleanings or 9 cleanings or 10 cleanings, but he cannot do 11 cleanings. So the number of cleanings has to be less than or equal to 10. So x has to be less than or equal to 10 because x is the number of cleanings. That's what I declared earlier. All right, let's look at something else. It says less than or equal to 4. Well, let's go find 4. Here's 4. It says that Dr. Lee cannot do more than 4 fillings per day. All right, so he can do 1, 2, or 3, or 4, but he cannot do 5. So the number of fillings he does per day has to be less than or equal to 4, and y represents the number of fillings, so y has to be less than or equal to 4. Now these last two constraints are going to be pretty consistent throughout the entire lesson today. I'm going to be adding these to every single one. Something has to be greater than or equal to 0, and then something else has to be greater than or equal to 0. That is just common sense. What that means is when Dr. Lee schedules appointments like his receptionist schedules his appointments, there is no way that his receptionist is going to be able to schedule -1 appointments. You cannot you cannot schedule negative numbers of appointments. You can either schedule none or you can schedule positive numbers. So basically, what number 4 and number 5 is saying is that the number of cleanings has to be either 0 appointments or more than 0 appointments. And the number of fillings has to be either 0 appointments or more than 0 appointments. He cannot schedule negative numbers of appointments. So this is just x and y. They both have to be positive numbers. That's all that's saying. So what I'm going to do now is do some shading. I'm going to do some graphing and shading. So I'm going to start by graphing number 4 and 5 just because those are pretty easy. X has to be greater than 0 and y has to be greater than 0. So if I look at that as x equals 0 and y equals 0, those lines are right along the axis. All right, so basically everything positive is fair game, nothing negative. Perfect. Let's go ahead and let's do number 3. I'll just go up. Y is less than or equal to 4. All right, well, if I look at that as y equals 4, the graph y equals 4 is right here. All right, y is less than or equal to 4, which means I'm shading everything below. All right, now let's move up. X is less than or equal to 10. The graph x equals 10 is going to be right here. 2, 4, 6, 10. X is less than or equal to 10 means I'm shading everything this way. So I can already see that I'm getting an overlap right there. Now let's go ahead and graph my last line. Y is less than or equal to negative 0.5x plus 7. Okay, plus 7. So I'm going to go start at 7. 1, 2, 3, 4, 5, 6, 7 is right here. And negative 0.5x is just a fancy way of saying negative 1/2 x. So I can go down 1 over 2. Down 1 over 2. Down 1 over 2. And then connect that line. All right, and then it said y is less than. So I'm shading underneath, everything underneath. All right, now if you can see, I have a lot of colors up here. Wherever I have blue, purple, green, and red shaded is going to be my feasible region. Right here, all the way down here, all the way over here. all of this area right in here is my quadruple shaded region. In this case, it was 5 shaded. I had 5 different lines that I graphed. All of that is where every single one of those shadings overlaps. So my last step here, test points, test the corners of my shaded region. I'm going to go ahead and pick those points off of my graph. So one of them, pretty easy, is at 0, 0. I'll test that point. Let's test up here, 0, 4. Let's test another one. This one's pretty easy. 10, 0. Let's test another one. Let's find another one. This one right here is a corner, 10, 2. And then finally, I have one more corner. It's right here. And it's kind of hard to see right here, but if you graphed with your pencil, it's probably easier to see more specifically. It's actually 6, 4. It's actually right here, sorry. 6, 4. Alright, so what I'm going to do now is I'm basically going to take each of those points, x, y, and plug them in to my objective function and just see what I get. Alright, when I plug in 0, 0, I get c equals 0. Don't forget my objective function is c equals 40x plus 95y. Alright, when I plug in 0 for x and 4 for y, I get c equals 380. When I plug in 10 for x and 0 for y, I get c equals 400. When I plug in 10 for x and 2 for y, I get c equals 590. And then when I plug in 6 for x and 4 for y, I get c equals 620. All right, let's go back up to my word problem and see exactly what they were asking me. It says, the very end of the sentence, or sorry, the very last sentence, says, find the number of each type of appointment that maximizes Dr. Lee's income for the day. Maximizes is the key term there. Basically, what is the biggest number that I found? 620. That was the biggest number. So 6, 4 is my answer. X, y. He should schedule 6 cleanings and 4 fillings in order to maximize his profit for that day. So he should schedule 6 cleanings and 4 fillings to maximize his revenue or income. That will get him the most money out of every day if he schedules 6 cleanings and 4 fillings. So that is according to all the constraints, all the time constraints, all of the money constraints, everything like that. We figured out that 6 cleanings and 4 fillings was the best case scenario to maximize his income for that day. All right, let's move on to number 2. It says a concert tour plans to advertise upcoming tour dates. The advertising budget is $60,000, and the tour manager will focus on primetime television and radio commercials. She would like to have between 30 and 60 radio commercials. Use the table to find the number of primetime television and radio commercials that will maximize on-air time of the advertisements, but will stay within the budget. All right. So they give us a little table here. They say that radio advertisements are 20 seconds long and they cost $400 each, and then they say that television advertisements are 30 seconds long and cost $1,500 each. All right, so it says they're maximizing on-air time. Before we were maximizing his income for the day, so we were maximizing his, like, the money aspect of that word problem, but this time we're maximizing on-air time. So where it says objective function, notice it doesn't say cost in parentheses. Because our objective function this time is not going to be focusing on money, it's going to be focusing on the on-air time of the advertisements. So declaring my variables, I'm just going to say that X is simply the number of radio ads, and then Y is the number of television ads. All right, and then my objective function. If I'm maximizing on-air time, I really need to be focusing on the amount of time each of those takes. So my objective function, going by seconds, if each radio ad is 20 seconds, 20x is going to be part of my objective function. And then if each television ad is 30 seconds long, it's going to be 30y. So 20x plus 30y is my objective function here. Okay. Constraints, let's look at those. I have 4 of them. If you notice, 3 and 4 are just that greater than 0, greater than 0. You can't schedule negative numbers of radio ads or TV ads. So simply those two, x is greater than y. X is greater than 0, y is greater than 0. Because we have to have a positive number or 0 of radio ads and TV ads. We can't have negative 4 radio ads. That doesn't make any sense. The other 2 constraints are ones we really need to focus on. So number 1, something has to be less than or equal to 60,000. Where do we see 60,000 up here? Over here. Our budget is 60,000. So we're focusing on money right now. All right, so it says if radio ads cost $400 and television ads cost $1,500, basically we're saying $400 per radio ad. So 400x plus 1,500 per TV ad, so 1,500y. Whenever you find yourself saying per, it's always multiplication. You're always doing 400x or 3x or 5x or something like that. So all the money I spend on the radio ads plus all the money I spend on the TV ads has to be less than or equal to 60,000 because that's our budget. I can't go over that. Now, where it has that little arrow wants me to actually solve for y, so it's going to be easier for me to graph. It's going to be 2 steps here, so I'll have to add another line there. But first I'm going to subtract over my 400x to solve for y, just using my solving skills. And I get 1,500y is less than or equal to negative 400x plus 60,000. All right. Now my next step is just to divide by 1,500. And I get y is less than or equal to 400 over 1,500 reduces to 4 over 15, and then I just have a negative sign right there. X plus 40. Now, I didn't do that in my head, I did it in my calculator. So here's one of my equations of the lines that I'm going to be graphing. And then my second constraint says 30 is less than blank is less than or equal to 60. So something has to be between 30 and 60. Well, let's look at my word problem. Look at the sentence that says, she would like to have between 30 and 60 radio commercials. That's focusing on radio commercials. So the number of radio ads or radio commercials, which is X, has to be between 30 and 60. Okay. So now what I'm going to do is graph all these lines and do some shading. So I'm going to start by graphing 3 and 4. I think those are the easiest. X and Y have to be positive, so I'm just going to go ahead and graph those lines here and here. Basically everything positive is fair game. Okay. I'm going to go ahead and graph that between 30 and 60 now. If I graphed x equals 30 and x equals 60, basically I'm shading in between there. Now, the one thing you have to keep in mind is when you're doing these graphs, sometimes you're not going to be counting by ones. In my first problem in the notes, I was counting by ones on my graph, but because I go up to 60 here, and like in the other equation in red, I have plus 40, I'm actually going to be counting by 4s on my graph, and I came up with that after thinking about it for some time, it might take you a couple minutes to figure out what you're going to count by. You can count by 2s, you can count by 5s, you can count by 10s. I'm going to count by 4s just because it makes the most sense to me. So let's see, if this is 4 here, 8, 12, 16 would be here, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60. So I just kind of wrote some out. I didn't write out every single one just because my marker's too big. This would be 4. This would be 16, 20, 24, 28 would be here, 32, 36, 40, 44, 48, 52, 56, 60. Okay. So now I'm going to go ahead and graph that less than or equal to 60 and then greater than or equal to 30. So x equals 30 and x equals 60 is what I'm going to graph. Well, 30 is actually like right here because it's between 28 and 32. So my line like falls right in here. And then my 60 right here. Now it says that x is between those two numbers, which means I'm going to shade everything in between. And then finally, that weird equation there, negative 4 over 15x plus 40. Okay, so I'm starting at 40. And what I'm doing is I'm going down 4 over 15. Now, it might seem super weird right now, but going down 4 is going to be easy because it's just one little block. Because I'm counting by 4s, just one of those is 4. And then over 15 isn't going to make sense now, but it will. So down 4, right 15. Now 15 is like right here. So here's 1 point. Down 4 over 15. Now if I actually look at my graph, I started at 0, then I went over to 15 right there. Then if I go down 4 and I go over another 15, I would technically be at 30, which is exactly where that green line is. So my next point is right here. And then my next point, down 4 over 15, that would be at 45, so it would be right past this line here. And then my next one, down 4 over 15, 45 plus 15 gives me 60. So actually my points landed pretty nicely on this graph. And it said x is less than, so I'm going to shade everything. I'm sorry, y is less than, so I'm going to shade everything below that line. So now I have to think, where do I see 3 different colors shaded? Well, it's actually right in this box, right here. Everything in here. Okay, so my next step, my last step, is just to test all of those corner points. I'm going to go ahead and look at my corner points. One of them is at 30, 0. One is at 60, 0. One is over there on the right corner, 60, 24. And then one is at 30, 32. Now it's going to be a lot easier for you to see that on the graph that you graph with your pencil because you'll be more precise than I am with these markers. But let's go ahead and test these points. So one of them was 30, 0. One of them was 60, 0. One of them was 30, 32. And one of them was 60, 24. Alright, so I'm basically plugging in those numbers into my objective function. Now I'll remind you what that is. That was 20x plus 30y. Gave me my c value. So when I plug in 30 for x and 0 for y, I get c equals 600. When I plug in 60x and 0 for y, I get c equals 1200. When I plug in 30 for x and 32 for y, I get c equals 1560. And when I plug in 60 for x and 24 for y, I get c equals 1920. So let's see. My question asked me to maximize the on-air time. So basically I'm looking for the biggest value that I found, which was 1920. So that point, 60, 24 is the max, is how I maximize my on-air time. So they should schedule 60 radio ads and 24 TV ads. All right, let's move on to the third and final one from the notes. Okay, it says a rancher is mixing two types of food, brand X and brand Y, for his cattle. Each serving is required to have 60 grams of protein and 30 grams of fat. Brand X has 15 grams of protein and 10 grams of fat and costs 80 cents per unit. Brand Y contains 20 grams of protein and 5 grams of fat and costs 50 cents per unit. How much of each type of food should be used to minimize the cost for the rancher? Oh, we're minimizing here. I'm going to go ahead and circle that right away. I'm going to look for the smallest value when I plug in my corners of my shaded region later. Declaring my variables. This is pretty simple here. Two types of food, brand X and brand Y. I'm going to call X brand X and Y brand Y. Did that on purpose. Pretty simple. And my objective function, or my cost, now I am focusing on money here. I'm minimizing my cost. So I need to focus on how much money each thing costs. Okay. So if my brand X costs 80 cents per unit, and my brand Y costs 50 cents per unit, that's what my objective function is going to be. Now, 80 cents is only 0.8 of $1, while 50 cents is 0.5 of $1. I'm going to use those decimals instead of 80 and 50. So 0.8 times my brand X plus 0.5 times my brand Y will give me my objective function, or my total cost. Basically 80 cents per unit of brand X and then 50 cents per unit of brand Y. Okay. So the rancher's mixing types of food with protein and fat. Each serving is required to have 60 grams of protein and 30 grams of fat. And then brand X has a certain amount of protein and fat, and then brand Y has a certain amount of protein and fat. So I'm basically going to see like what is the ratio of mixing that I can have for this food for the cattle. So one of my constraints, now we didn't spell them out for you this time, we want to see if we can get it on our own. They will be spelled out, but we just wanted to see if you can do it on your own. So one of the constraints is going to be about protein. One of the constraints is going to be about fat. And then two of them, 3 and 4, if you kind of remember back to what we were doing with the first two, those are going to be the easy ones. Those are going to be the ones that have to focus on positives. So I'm going to write those really quick first. I know that I have to have a certain amount of protein and a certain amount of fat. I cannot have negative protein or negative fat. That doesn't make any sense. So X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. Those are my two constraints that I already know. Those are the simple ones. All right, so let's focus on 1 and 2. One of them is going to have to do with protein, and one of them is having to do with fat. Let's look up here. It says that brand X has 15 grams of protein, and then it says that brand Y has 20 grams of protein. Now in my requirements, each serving is required to have 60 grams of protein, So looking at all of that, if I have 15 grams of protein per unit of brand X and 20 grams of protein per unit of brand Y, I'll go ahead and write that out. 15X plus 20Y. That has to be related to 60 somehow. So I have to have 60 grams of protein in my mixing of my food. Now, it can't have less. It could have more, but it has to have at least 60 grams of protein total, which means I'm going to set that greater than or equal to 60. All right. Now my other one is going to have to do with fat. So brand X has 10 grams of fat, brand Y has 5 grams of fat, and I have to have at least 30 grams of fat total. So 10X plus 5Y has to be greater than or equal to 30. Those are my requirements for the food. Now I'm off to the side here. I'm going to go ahead and solve for my Y values so that I can graph those lines. Right up to the side here. I'm going to subtract 15x first and get 20y equals negative 15x plus 60. Then I divide by 20. And I get y is greater than, not equals. I should not have said equals, I should have said greater than or equal to. There we go. Negative 15 over 20 reduces to negative 3 over 4. 60 over 20 is just 3. So here's one equation of one of my lines. And then the other one, when I subtract over 10x, I get 5y is greater than or equal to negative 10x plus 30. Divide by 5. That'll all go in really nicely. I get y is greater than or equal to negative 2x plus 15. Okay. So the highest y value that I have here is 15 from my equations. So I'm just going to go ahead and count by ones on this graph, make it easy on myself, because I can. So I'm going to go ahead and start by doing the easy ones. Y and x both have to be greater than 0. Graphing my lines. Basically, anything positive on this graph is fair game. So anything up here. Okay. And then I'll do my blue one. Y is greater than or equal to negative 3/4 x plus 3. Okay, well, I'm starting at 3.
Amaya Taylor, Madison Peters, Caleb
And I'm going down 3, right 4. That's pretty easy. That was just 2 points. And it says that, let's see, y is greater than that. So basically anything above that line. Let's do the green one now. Y is greater than or equal to negative 2x plus 15. Well, 15 is actually... Oh, I'm at 6. I'm at 6. Because if you scroll down here, I did this math wrong. Whoops. 30 divided by 5 is not 15. 30 divided by 5 is actually 6. Alright. So, let's do that. Plus 6 is right here. And negative 2x down 2 over 1, down 2 over 1, down 2 over 1. Alright. Now, the bad thing about this is that, well, let's do my shading first. Y is greater than or equal to. So bigger than. So anything above that line. Alright, let's see if I can point out where I'm shaded all of them. Basically everything from here to here to here, all the way over. So everything that's in black right here is shaded by all of those shadings, which means any of that is fair game. Now, that makes sense because when the rancher is mixing food, he could put 1,000 units of brand X and 1,000 units of brand Y and mix food for his cattle. He could mix in 1,000,000 units of brand X and 1,000,000 units of brand Y and mix for his cattle. It really doesn't matter. So basically, anything in that shaded region is fair game. Let's go ahead and see if we can pinpoint the corners of that. Now, there's no corners on the top, like way up here in the top left. There's no corners up here because it goes to infinity this way and this way. But there are corners here, here, and here. All right, let's see if we can figure out what that first corner is. The first corner is actually right there at 6, 0. I'm sorry, 0, 6. 0, 6 is one of my corners up there. Over here on the bottom right-hand corner, like right here, that corner is 4, 0. And the only bad thing about the corner in the middle is that it doesn't fall right on a point. Now, it might look like it does, but it actually doesn't. Because the only thing we know about that is that when we were graphing that blue line, we went down 3, right 4. We didn't go down 1, right 2, down 1, right 2. So it doesn't actually fall right on a point there. Now, the things you do on your homework and your target check won't be this hard, but I'm just going to show you how to do this just in case you were presented with this somewhere, sometime in the future, you would know how to do it. If you are given 2 lines or 2 equations of 2 lines, and we want you to figure out where they intersect, you can find that point of intersection by solving that system of equations. That's what we're doing when we're solving systems of equations. Substitution and elimination is how we get that point where they intersect. So I'm actually going to take this and this, which are those 2 lines, and I'm going to see where they intersect. So off to the side here, 15x plus 20y is greater than or equal to 60. You can actually just say equals to when you're doing solving. And then my other one, 10x plus 5y is equal to 30. I'm going to use substitution and elimination to solve here. See where my x and y point is, where they overlap, where they intersect. All right, so I think the easiest thing would be to multiply that second equation by 4. So I would get 40x plus 20y is equal to 120. And then I still have that top one, 15x plus 20y is equal to 60. And all I'm going to do is subtract those 2 equations. So 40x minus 15x gets me 25x. Those cancel, is equal to 60. When I divide 60 by 25, I get x equals 2.4. And then I can go ahead and plug 2.4 back in for one of these equations to get my y value. I'm going to plug it into that first one. So 15 times 2.4 plus 20y equals 60. 15 times 2.4 is, let's see, 15 times 2.4 is actually 36, so it works out kind of nice. 36 plus 20y equals 60. When I subtract over 36, I get 20y equals 24. And then I get that y equals 1.2. So 24 divided by 20, I get 1.2. All right, so there's my other point, x comma y, and I can write that over here on the left. 2.4 comma 1.2 is my last, third, and final point. I only found that by doing solving. Like I said, I wouldn't ask you guys to do something that hard on a test or a target check or anything, but I'm just showing you how you can do it. All right, so when I plug 0 in for x and 6 in for y, I get c equals $3. When I plug in 4 for x and 0 for y, I get $3.20. And then when I plug in 2.4 for x and 1.2 for y, I get c equals $2.52. Now, if I look back up at my problem, it asked me to minimize the cost for the rancher. So the smallest value here is 2.52. So we actually did need to solve for that point because the cattle rancher needs 2.4 units of brand X and 1.2 units of brand Y to minimize costs. And that is our answer. Alright, so basically the thing we're adding to target 14 is those word problems. It's just linear programming though from targets 12 and 13. I'm just adding my own constraints. Then I'm graphing those lines, shading wherever I need to shade, figuring out which region is shaded by all of the shadings. Then I am picking out those corner points and testing those, seeing if I need max or min, and then getting my answer.